Okay. Hello and welcome to our workshop today. We're talking about 3D printing your own drone. In this case, a racing drone. Of course, you could print other types of drones. And this is in collaboration with Q Project at UC Merced. So, what makes a race drone? Uh, a race drone is pretty much specifically built for racing. It's designed to go high speeds, and you're able to also do some pretty crazy stunts. We'll see some videos upcoming shortly. So I want to start off with a quick clip. So let's go ahead and view this.
In season 2 in Munich, had a really rough go in the first round. I felt like my opportunity to automatically advance to finals in London was taken away from me. Losing in Munich made me hungry. Racing is a mental game, right? It's all about how do you handle your emotions, block out the distractions, and fly your race. Without that experience, without that practice, without having that pressure been on you before, it's hard to remain competitive. As soon as the goggles come down, Nerd comes out, and it's time to win.
Nerd's making a move. Nerd hit green, fakes the pass. He found an extra gear.
Whoa! He took that faster than anyone we've seen yet. Nerd's on fire.
Nerd well in front through the hex ascent. Gab second.
Gab is running out of time if he wants to catch Nerd.
Nerd wins heat 4.
Watch out for him in the final.
Okay. I think we may have had some internet problems. Give me a second. Okay, but pretty much what that video was, it's the drone, a clip from the drone racing league, and as you could tell, this is pretty much a real sport. They have events where people compete, and then this is just a quick clip from one of their events, and I thought it was pretty crazy because I mean they have like commentators and stuff like just like in other sports, so I thought it was nice to watch.
I went for business winner.
Okay, so as we saw in the video, um, the guy in the video had some sort of goggles, and these are first-person view goggles. You can see the guy on the left is with his drone. He has some sort of goggles on his head. Those look pretty big. Of course, there's different designs, different brands. The picture on the right shows a monitor. It's kind of like a small TV display, or yeah, pretty much a small display. So instead of using the goggles, you can also use this. That's what I've been using lately, just because I find it just pretty simple to keep an eye not only on your camera, but then you could also like just lift your head and check on your drone in like first person, in real time view, rather than just the goggles. So why built and not bought? If you get a do it yourself kit, you pretty much have to source the drone frame, whether that's in our case you 3D print the frame, or you could go online and buy a frame that's already made. For example, some carbon fiber or some other plastic frame. You also have to identify compatible parts that will work together to make the drone fly. And of course, you also have to assemble the parts together. And in comparison, if you get a kit, ready to fly kit, pretty much these are plug and play. and there's minimal setup required. It's you pretty much almost turn on the controller, the drone, maybe plug in a couple things, and you're ready to fly. These are a couple 3D printed drone designs. On the left, it's you could see it kind of has this board around it. Um, and then the middle one, oh, the middle one is pretty interesting because it has an extra camera. You can see right here, there's a tiny camera. That's the one that's used for first person. Um, that's the one you see in your goggles. And then the camera on top is where you would place like a GoPro or like some other higher definition video capturing device. I forgot what brand that is, but it's I don't think it's a GoPro, but it's pretty much to capture high quality images. So the videos you're gonna see on YouTube and stuff, most likely they're captured with this camera, with the high definition camera. Uh, this drone on the right is the Peon 230. This one, oh, so all these three designs were found on Thingiverse. So these three are 3D printed. I like this picture because it kind of shows the bare frame, and you could tell it's actually sitting on the bed of a 3D printer. So that's how you know it's one of these. You know it's 3D printed. This is a one of the ready to fly kits that I was talking about. This you could order it on Amazon or other online store, and it's pretty much almost ready to fly. Um, so as you could tell, this is the Immersion RC Vortex 230, and this is what you get in the package. So you get the frame, the camera's already there, all the electronics are pretty much already on the drone. You can see the motors, they're already in place and wired. So the only thing you have to do is put the propellers onto the motors, and of course use the nuts to tighten that up, and then plug in the antenna and maybe the battery. Yeah, and that's pretty much it. So now let's talk about the QRD build. This is the drone that I designed using a CAD software, Fusion 360. Here's a couple pictures of the final product. You see on the left, it's just sitting on my desk, but we're going to see a video of it flying in a bit. So here's the wiring diagram that I used. So you have the four motors, the electronic speed control. So all these connections, you either have to solder them, or some of them come with connectors. So in that case, then it would be kind of like plug and play. But you do have some soldering here. So now let's go through some of the steps that from when after I finished 3D printing it. This is the steps that I took. Actually, let me take a quick break from the PowerPoint and show you guys the video. I have it printing, so you can see the arms right here are blue. I actually broke these because I forgot to print it 100% solid, so I printed it like I think like 10%, so it's pretty much fragile, like really hollow. So now let me switch over. If I could figure out how to mute this.
Armand was asking what QRD stood for.
Oh, I don't know. I the RD stands for Racing Drone. The Q, I don't know. Q project, I guess. I don't really have an explanation for that. Okay, so let's check out the printing of it. All right. Can you guys see this one?
Yeah.
So these arms are being printed 100% to be fully solid, and hopefully these will stand a better chance at not breaking.
How long does it take to print it solid?
Hold on. Sorry, can you repeat that?
Yeah, I was saying, how long does it take to print them solid? Because when I've been testing, I've just been doing usually like 15, 20%. If you're talking about like the infill.
Right. So yeah, it does take longer. I think these arms were supposed to take like an hour or two each because the four of them took 8 hours to print.
Yeah, that's a
Wow,
long time.
that's a long time.
Yeah. I just kind of had to hit print and walk away, go on with your day.
How did you put that in the settings?
So I use Cura for the slicer. I could go through that. Let me see. Oh, so you pretty much just change the infill. Give it a few seconds to boot up, and I could easily show that.
In the Creality software, is it the same? Is it called infill?
You know what? It's different softwares may name it different, but I think a good way to check. Okay, let's see. There it is. Um, so yeah, in right here it says infill, and you could change it to whatever value you want. They might call it something like density or solid something. A good way to check is if you
Oh, you could do the layers, right?
if you do a print preview. So for example, if I slice this, because if I go up here to preview, you see the layers. Well, actually, this is a bad example. Oh no, it's pretty decent. So you see this stuff right here, how it's fully solid. That would show you that it's 100%.
What about the other stuff? The bottom layer or the layer that's closest to the green arrow?
Uh,
Oh, that's like where the screws are supposed to be.
oh, this stuff, yeah. So I wouldn't print it like that actually. The way I would print it is I would lay it flat, right?
Yeah.
Something like that, and then hit slice.
You save a lot of time doing that too.
So yeah,
2 hours.
Yeah, that's a good amount of time saved.
so yeah, you can see a better view right here.
Okay.
It's pretty solid all the way. So for example, we did like 10%. It wouldn't be like this. In fact, it would. Let's go ahead and do that just to show. And you're gonna notice a decrease in the print time also, but at the same time, it's going to get weaker, right? Because it's not full. Oh, you can see it, yeah, right there. All right. Let me move this to the side and continue on. So yeah, the first step was pretty much attach the arms to the base. You can see it on these pictures. And then I used some fasteners from Amazon. Then these standoffs were actually ordered. I tried printing some, um, and they worked on a previous drone, but then they broke too easily. So I decided to just buy some, hoping these will do a better job. And then this black square thing is the autopilot, not the autopilot, the flight controller. um, So yeah, you pretty much connect the motors to this, and this tells them what to do. We have the motor over here on the left, and then this black thing is like this silicone pad. It tries to help reduce the vibration from the motors. And then we can see the camera over here on the right. This was also 3D printed, the holder for the camera. Oh yeah, here's a better pic. Once it's locked into place, and then we can see more of the wires over here. Now we have the oh, there it is. Now we have the electronic speed controller. It's this big square that has the 20A. And I like this one just because it saves space. It's if you compare it to other ones, this one's it has a small form factor. Um, and then we're gonna see. Okay, there we go. The we have a battery eliminator circuit, and then here's a top view, and this is pretty much just finishing it up. You put the top lid, and that's 3D printed, of course. The receiver uh, for your controller, and then the transmitter for your video is right here. So I like using Velcro just because it's a good way to hold it in place. And then on top of that, I use like a zip tie or some other thing to hold it. Have like a double layer security. So let's take a look at how much it costs to build this. Um, so you can see a list of items, and the total came out to 344. You could probably get it cheaper if you do like Banggood or something like that. I think these were from Amazon, so the price could be a bit cheaper. And it's also important to note that for example, lock locknet or the thread spaces, the units per item, they give you a whole bunch, so like you end up with a bunch of spare parts um to either replace them if they break or build another drone or for another project. Let's take a look at one of the video from this actual drone. Um, the video is not that high quality just because it wasn't from a GoPro, it's from that tiny little camera.
What was the software you used to code the thing? The flight controller or any other piece of drone?
To hold on, I
Oh shoot, what happened there?
okay.
Was
Sorry.
this the one that crashed?
Yeah, this one crashed. And that's where it broke actually. Because the camera got disconnected when it crashed, so the video just cut out. Sorry, what were you saying?
Oh, the software?
That I used to for the drone?
Yeah. All the drone parts.
The only software you need is, I guess it would be ideal to have a drone racing simulator so you could practice crashing and not actually break your drone because
Oh, I was talking about how do you code the flight simulator? Or do you do any coding for that?
oh no, you don't not for this one. There's a program called Betaflight, and but that's not really to code it. That's more like to set up the flight controller. So like you hook up your controller and you're like, oh, max position for the throttle is this, and then you move your throttle down. This is the lowest position. Things like that.
Oh,
It's
okay.
there's not really coding for this drone.
Can you show the video again?
Yeah.
Do you know why it crashed? Because I know I saw that it was going high up and then it lost connection or something.
Yeah, so for some reason I lost video feed and then I panicked and I brought it back down and then I just crashed. Yeah, that was user error. I guess I freaked out.
There'll be plenty of training before the big race, though.
Oh yeah.
Could you add more weight on it? Like, for example, I have the Panda wireless um, network cable. Could we add that instead? Like, how much weight can the drone support?
Good question. I guess that would depend on your your battery and the size of your motors, maybe. um, but yeah, obviously, like the more weight you have, the faster your battery runs out, right? Because it's carrying
Yeah.
more.
Do you think with the filter or with the 3D printed frame with the lower infill would be better, or do you need the 100% infill?
So I built the Peon 230 drone before, and that one I think it was like 50% infill or something, and that one broke um pretty easily. So I think it has to be 100%, or yeah, I would say um it might be safer just to do 100% because you don't want to go out to like a park and stuff, and then the first crash, your drone already broke, so you have to go home. You know.
Okay, I understand. So this drone right here that crashed was because um, it had the lower infill.
Oh yeah, that's why it broke.
Okay,
Um, I mean
why?
it.
Do you think you could have saved it with your drone skills if you had some? Like,
Yeah,
like a
that's
professional.
that's definitely a good point. Like I'm an amateur, drone racer. So of course, if I we're gonna see a video upcoming in the slides, and then if I had the skills that these guys had, yeah, that wouldn't have been an issue. Um, yeah. Uh, let me continue with the thing. I think it's the next slide. Oh yeah, here it is. So we're only gonna watch maybe like a minute or two. Okay, so I like this video because on the lower right over here, that's the footage from their um that's the footage from their FPV camera, that from the small camera. On the big screen is the footage from their GoPro or high definition camera, right? And on the lower left is them actually controlling the controller. So that's why I picked this video.
Damn, they really know how to fly drones.
Imagine doing this at the UC campus.
Just get a bunch of UC administration just trying to shoot down the drone. He just doing a bunch of stunts. Do you have a video of the actual drone, what they built?
Good question. I I do not. I think here, let's see. Maybe we pull it up here. Oh, it looks like they do have it. Oh, it's from that one team.
Yeah, the one I showed you.
Yeah. So this is what they use. $600. Oh, looks pretty nice. It looks like it comes with the camera and everything.
That's about double what you paid.
Yeah. So I think yeah, most importantly would be to get the skills first. Otherwise you're gonna get an expensive drone and break it, and oh, there goes another 600 you gotta pay. So but yeah, you get you get the idea. There's some people out there with real skill, um, doing real cool stuff, and there's many ways to get involved. These are just three of the racing, I guess, companies or yeah, communities. Uh, Drone Racing League is popular here in the United States. Velocidrone is more of like Europe, and then Multi GP is kind of like world wide, and they have online forums, YouTube videos like the ones I showed. There's social media groups, Facebook, Instagram, Reddit, and then there's local events. Probably not right now, but you know, as things start to open back up, I'm pretty sure there's gonna be some. But yeah, that's pretty much for the presentation. Uh, are there any questions?
I don't think I have any more.
Yeah, no questions. Thank you, Jesus, for this workshop.
All right.
It was really great, and I hope to get Q Project building drones soon. And
Yeah.
hopefully we'll have our own video on how to build a drone, just like what you built.
Yeah. Maybe some crazy stunts.
Yeah.
All right. But yeah, uh, thanks for watching, and hopefully you share the the video and get inspired to build your own drone.